Welcome back to another video. This is going to be two examples from the lines that we were supposed to do, but we didn't do because I was pressed for time. I want to show you these examples because they are not skew. You're going to have to figure out which one's intersecting and which one's parallel though. First of all, I want you to try this and tell me if it's parallel, intersecting, or skew. Give you a few seconds. Few seconds is not enough. You probably should pause it, but I'm going to start right now. So we'll do x and z this time. We'll do x and we'll do y and z because we did x and z on both the examples. So let's go. So we'll have minus 2 plus t has to be equal to 2 minus 2s, and minus 4t plus 5 has to be equal to, s minus 4. So what you can do is you can move everything to the other side. T equals 4 minus 2s, and then this line does nothing. This is how I like to do my work. So the line doesn't actually do anything like that. Multiply by 4 on top. Multiply by 4 on top, you will get 4t equals 16 minus 8s, and minus 4t equals s minus 9, and then you can add the equations, which will get you 0 is equal to minus 7 minus 7s, for which you can easily solve s equal 1. S equals 1. So s equals 1. Let's plug it back into one of the equations. Let's see. So 2 minus 2s. 2 minus 2s is 2 minus 2 is 0. So that has to be 0, and this also has to be 0 as well. So t has to be equal to 2. Right? Or t has to be equal to 2. So now if you plug it in this one, they also have to be the same. Remember, the x's have to be the same for it to be an intersecting point. Otherwise they are skew or parallel. But in this case, if you've worked it out, it shouldn't be parallel because you can't multiply anything. You have to multiply 2/3. 2/3 times 3 is 2, right? 2/3. You have to multiply 2/3 to get 2. But if you multiply 2/3 here, you get 2/3. You don't get -2. So that's why the parallel thing just does not work. So s is equal to 1, t equals 2, and if we put it in here, 3 times 2 is 6, x equals 6 on top, and 2 plus 4 is also 6. So these are intersecting. Intersecting lines. Right, and where are they intersecting at? They are intersecting at 6, which we already established, 0, and 1 minus 4 is -3. So there you go. Intersecting at 6, 0, -3. Let's go to the next question. Same thing, do the problem. Check for parallelness first. That's usually what I recommend, and then do the thing, because if it's parallel, you don't need to do anything. You just need to say it's parallel. Okay, I think you guys are ready. Now, these two lines could actually also be the same line, but they're not. And the reason why they're not is because if you in order for you to have the same line, the constants will also have to follow that multiplication. So this is t, right? You multiply 1 by 3 to get 3, so 1t times 3 gives you the 3 here. -2 times 3 gives you -6. 5/3 times 3 gives you 5. I'm sorry if you haven't paused the video yet, but that should already give you a clue that this line is parallel. There you go. So this is parallel. But 1 times 3 isn't 8, -7 times 3 isn't 3, and 4 times 3 isn't -1. If they were, then the lines would be absolutely the same line. It would be the exact same line, and we would have a great time because we wouldn't have to do any more calculations after that, I hope, if you guys have a test on that. But anyways, these are parallel because we have determined that when you multiply the coefficient on top specify a fixed number, in this case 3, you get the coefficient on the bottom, and it works for all three coordinates, so they are parallel. So that's it. I'll see you next time for some different problems.